Today, we're going to be going over the acid-catalyzed dehydration of alcohols to form alkenes. So this is one of the most important elimination reactions in organic chemistry and is a classic way to make an alcohol convert to an alkene. This reaction is an E1 elimination reaction. So that means it's going to be a two-step mechanism with a carbocation intermediate. The general reaction for this is going to be our reactant with an acid catalyst, so I'll just label that as an H+, and then we'll see heat as well, and our product is going to end up being an alkene. And we're also going to get water out of it. Let's take a deeper look at the step-by-step mechanism. Like I said, this is an E1 elimination reaction, meaning we're going to have two steps. The first step is going to be the protonation of the alcohol. So the alcohol by itself isn't a good leaving group, so the acid is going to protonate the hydroxyl group and convert it into water, which is a much better leaving group. So in our example, we can have this molecule, and then if we take our concentrated sulfuric acid, let's say, any acid catalyst, we're going to have an HO here at the end. And we have this inductive effect, this electron withdrawing effect, making this oxygen a partial negative and the hydrogen a partial positive. So these electrons from the alcohol can grab that hydrogen because it's a little bit weaker. What we'll see as a result is the exact same molecule, nothing's going to change, except that OH group is going to become an H2O. And it's going to be plus. Our oxygen is going to have a plus charge. Now this is where our E1 elimination mechanism comes in. H2O is a good leaving group, so we're going to give it these two electrons and create our carbocation, just like this. And then we get water as well. I want to note that at this stage, if there is a more stable carbocation that could be formed with either a hydride or methyl shift, that could occur. There are rearrangements in this step. After this, we're going to have deprotonation. What's going to end up happening is this H2O is going to come back and grab this hydrogen. The hydrogen is going to donate those electrons in that bond to form that double bond, getting rid of our carbocation. And our final product here is going to be our alkene, and now H3O plus, which can act as a catalyst and will be regenerated. If this is the catalyst that we used, it'll be regenerated so that we can do this whole process again. Let's go through a step-by-step example. So let's dehydrate this 2-butanol with our H3O plus and heat added. Again, the first step is going to be the protonation of our hydroxyl group. So one of our lone pairs on our oxygen is going to attack one of these hydrogens, and we're going to get the exact same structure, except we're going to add a hydrogen. That's going to give our oxygen a plus charge. Now it's going to be a good leaving group. In a new step, we can show the electrons going to that oxygen to make it neutral, and then our product for this will be our carbocation, and then our H2O. This is the part where we look if there's any rearrangements. We have a secondary carbocation right now. If we move it with a hydride shift to the left, we're still going to have a secondary. If we move it to the right, we're going to get a primary. So there's not a more stable rearrangement we can have. We're going to stay with the molecule that we have. After this, we're going to have our carbocation, and if I label our beta hydrogen, we're going to have a water that we formed in the last step attack that beta hydrogen. And those electrons will get donated to that bond and form our alkene. So our product here is going to be 2-butene with our H3O plus regenerated. We can have the Zaitsev product or the Hoffman product, so we can have 2-butene or 1-butene. But in this case, since we don't have a lot of steric hindrance and our nucleophile is small, we're going to see the Zaitsev, or the more substituted product. If this video did help you, please consider liking and subscribing as it really helps the channel. And if you want to see more videos, my organic chemistry playlist should be listed up on the screen. Thank you so much for watching.